In 3.4, parallel lines and triangle angle sum theorem. There's a lot more numbers in this and a lot less proof. So hopefully this one's a little bit easier for you guys to understand. All right, big theorem here. The sum of the measures of the angles of a triangle is 180. So if you take all three angles of the triangle, you add them up, they're going to equal 180 every time, all day long. All right, so let's try this. If you look at the triangles, the triangle on the right only has one angle measurement and two that we need to find. The triangle on the left has two angle measurements and one that we need to find. So we probably need to start with the triangle on the left side first, and then we can move on to the other triangle. So let's start with that. Okay, so you know the triangle on the left adds up to 180. So we're going to take 180 minus the 39 at the top, minus the 65 on the left. That leaves 76 to put right here. Okay, now we have to figure out how to jump across so that we can do the other triangle. So if you look at x and y, the two of them together have to make 180 because they make a straight line. So if you take 180 minus 76, we get 104. Now I've got a triangle on the right that has two angles and one defined, so I can take 180 minus 21 minus 104, and then z would be 55 degrees. Okay? Got to be able to find the angles in a triangle all the time. Alright, to classify triangles by angles, equiangular means that all angles are congruent in the triangle. Okay, so all three of them are going to be 60 degrees because that's the only way that can happen. An acute triangle has all acute angles. That's just how it works out. A right triangle has one right angle and then two acute angles because they can't have any obtuse angles if they already have a right angle. An obtuse triangle has one obtuse angle and then two acute angles. Okay, this is not new. You guys have done this before, but just a reminder, a little refresher course. Alright, by sides. So if I tell you to classify by angles, you use the other terms. If I say classify by sides, you use these terms. Equilateral, all sides are congruent. Okay, which means all the angles have to be congruent as well. That's just how it works. Isosceles has two sides congruent. And then a scalene, all sides different. So all three sides will be different measurements if you have a scalene. Okay? Alright, so let's look at this. Classify the triangle by its sides and by its angles. By sides, it has these marks. These marks mean that those are congruent. So it has two congruent sides. So it's isosceles. And then in order to be isosceles, it has to have two congruent angles as well. These all look acute. So by angles, it would be acute. Alright, a little definition here. An exterior angle, this is an angle formed by a side and an extension of an adjacent side. So in the picture, I put the exterior angle out here. It's this angle on the outside of the triangle. It's just like you extended one side out and there it was. Okay? Remote interior angles are the two angles that aren't touching the exterior angle. They're the non-adjacent interior angles. So they're not next to the exterior angle, then they're called remote interiors. Okay, these definitions are important for this theorem so that you understand what's going on. The exterior angle theorem. The measure of the angle on the outside, the exterior angle, equals the sum of the two remote interiors. So in this picture, the measure of angle 1 is equal to the measure of angle 2 plus measure of angle 3. Okay, the exterior equals the sum of the two opposite angles. Alright, So let's try one. So for this one, angle 1 is equal to 40 plus 30, so it would be 70. You could also add up the triangle, find this angle in here, subtract from 180 to find angle 1. It'll do the same thing. Alright, same thing here. 113 is equal to 70 plus 2, so this has to be 63 in order for that to happen. You can also figure out that this is 67 right here, and then add up your triangle together to make sure it adds up to 180. Okay?